Hi, I'm Ryan Abernathy, CEO of Earthmover. In this video series, I'm going to be sharing the main features of Arraylake, our new data lake platform for scientific data. Our goal with Arraylake is to give developers and data engineers a 10x improvement over their existing workflows with multidimensional array data in the cloud. In each of the videos, I'll demonstrate how Arraylake solves key problems for scientific data teams through example Python code in a Jupyter notebook. In this video, we're going to start with our simplest and most central feature, the data catalog. Before diving in, let's talk about what people do today and what's wrong with existing data catalog approaches. Most users of array data in the cloud today store their data directly in cloud object storage like AWS S3 in formats like netcdf, HDF5, or Zarr. This works okay in some ways. S3 is really performant and scalable, but the object store itself is not a data catalog, and the developer experience for discovering, managing, and sharing data through object storage leaves a lot to be desired. So to illustrate this, let's have a look at the ECMWF ERA5 reanalysis dataset. It's available through the AWS Registry of Open Data. This dataset consists of thousands of individual netcdf or Zarr files in a deeply nested hierarchy. Let's pop into a Jupyter notebook and look at what it's like to explore and work with this data. So here we're going to list the bucket where the data live. We can see a bunch of file paths. We can go deeper down into this hierarchy through the month, the year, the month, and finally reach some files that we might be interested in opening. So here the metadata about the data files is really encoded in these S3 file paths. And any other metadata that's not part of the file paths is hard to find. In order to provide a richer catalog, a lot of teams will then start tracking information about what's in S3 in a second location, a data catalog. And that can be as simple as a text file or a spreadsheet, or it can be as complicated as a separate relational database pointing to locations in S3. We don't think either of those is a great solution at Earthmover. This is obviously not a great developer experience just to browse through this bucket of random files. On the other hand, maintaining a separate data catalog means that we have to keep those two things in sync. So I'll show you how Arraylake solves this problem. So to get started, we're going to connect to an Arraylake repo. So what I've done here is connected to a repo called Earthmover Demos/Arraylake Features. So the repo is the core object that we interact with in Arraylake. It's a version-controlled hierarchy of arrays and groups that's analogous to a large Zarr or netcdf or HDF store. And what we can do is write some data into this repo. And so that's what's going to happen in this next cell. I have a little data ingestion pipeline. I'm going to read some of this data from the ERA5 public data bucket, do some light reformatting of it, and then write it back to Arraylake. And I'm using the xarray library to do all of this. When I write to Arraylake, I simply point xarray at my repo.store object, and that tells it where to store the data. I also specify a group within that store as a location for the data set. So once this has been run, this little pipeline is done, I can browse this data set through this nice widget in my Jupyter notebook and see the different arrays and groups that I created. Once I commit my changes, I can also go to the Arraylake web application and have a look at this data in the web. So I'm going to browse through this hierarchy I just created. Here I can see one of the data sets with a couple different data variables in it. And in addition to just file paths, I can see a lot of metadata that is associated with this data set, such as the institution. I can see the shapes of all these different arrays. If I drill into one of the arrays, I can see a lot of useful metadata like the shape, the data type, the chunking, and all of the array metadata. If the data were just sitting in S3, I wouldn't have any way to easily access or operationalize this metadata. But as I'm going to show you in just a second, we can actually now search against this metadata to find data that we're interested in. I'm going to move back to the Jupyter Notebook. I'm going to show how we can quickly pull that data back out of Arraylake, opening it with Xarray, and just plot some data. So here we're looking at a snapshot of global surface air temperature. Now the final thing we can do with this data catalog, as I just mentioned, is use the metadata to find data that we want. So here I'm calling filter metadata, looking for anything where the standard name matches air temperature, and that returns one data set from my repo. So taken together, these catalog features provide a big upgrade on the developer experience for working with array data in the cloud. In our next video, I'm going to show you how our transaction and commit mechanism creates much more robust data pipelines.